Hello everybody, my name is Shanshu Laktaria, studying in Sri Venkateshwara College of Engineering. Today I am going to give a technical seminar on the analysis of the effect of demand-driven dynamic parking pricing on a street parking demand. Under the guidance of N.A. Gowda sir, these are the contents of my PPT. Firstly, it starts with introduction, then the literature survey, methodology, block diagram, applications, results, conclusion, references. Firstly, let's start with the introduction of my PPT. The analysis of the effect of demand-driven dynamic parking pricing on a street parking demand is a study that seeks to understand the impact of dynamic pricing on the demand for a street parking. Parking management is an important issue for many cities, especially in areas with high levels of congestion and limited parking spaces. One approach to managing parking demand is dynamic pricing, which involves adjusting the price of parking based on real-time demand. The rapid increase in the number of cars has caused many problems such as cruising for parking and illegal parking. The study focuses on the effect of demand-driven dynamic parking pricing on street parking demand. It has been proven that parking pricing strategies can regulate the spatial temporal distribution of a parking demand and improve the efficient utilization of parking facilities. Designing a reasonable parking pricing scheme is regarded as an effective method to elevate parking problems. One approach to managing parking demand is dynamic pricing, which involves adjusting the pricing of the parking based on the real-time demand. Demand driving Demand driving dynamic parking price is an adjustment mechanism that can change the parking price for different parking facilities at regular intervals according to changing parking demand. Next is the literature survey. Here I have referred four papers. Firstly, let's start with the first paper, whose author is A. Mirheli and L. Haji Babai. The paper topic is utilization, management, and pricing of parking facilities uh, under uncertain demand and user decisions. In the year of 2020, the first contribution the paper contributes the paper this contributes the paper proposes a new parking management and pricing approach that considers both uncertain demand and user decisions. The approach aims to optimize the utilization of parking facilities and improve revenue generation for parking operator. This paper has a drawback of the paper does not consider the potential impact of external factors such as government policies or regulations on pricing management and pricing decisions. Next paper, the second paper, whose author is JLISSW and X Fenge. The paper title was Optimization of On-Street Parking Charges Based on Price Elasticity of the Expected Perceived Parking Cost in the year of May 2021. This paper contributes, the paper uses a case study of a certain business districts in China to evaluate the proposed approach and compare it with existing parking pricing strategies. The result shows that the proposed approach can effectively balance parking supply and demand and improve the overall efficiency of the parking system. This paper has the drawback of the case study used to evaluate the proposed approach is limited to a specific urban area in China, which may not be respective of other urban areas with different parking demand patterns, infrastructure, and cultural factors. The third paper, whose authors are BMO H. Kong and W. Wang, C. Wang, and RLI. The paper has the title of Impact of Pricing Policy Change on Street Demand and User Satisfaction in the year of 2021. This paper contributes that the paper finds the new pricing policy leads to a decrease in parking demand, especially during peak hours, and can and an increase in user satisfaction levels. The tiered pricing structure encourages shorter parking duration and reduces the time user spend searching for parking spots, leading to improve overall parking efficiency. This has the drawback of the study does not addresses the potential equity implications of the new pricing policy, such as the impact on the low income users who may be more price sensitive and unable to afford the new pricing structure. Now let's come to the fourth paper, whose author are C. Piccoini, M. Valtorta, and A. Mucoso. The paper has the name as investing effectiveness of on-street parking price schemes in urban areas in the year of 2019. The paper contributes on the paper develops a comprehensive set of indicators to evaluate the effectiveness of the pricing scheme, including parking of occupancy rates, parking duration, parking revenue, traffic volumes, travel times, and air pollution levels. This has a drawback of it can be modeled as realistic mobility model and compare the result. It will be applied in autonomous connected vehicles and are exposed to the physical and cyber attacks. Next, let us come to the objectives. This topic has main four objectives such as and first is the to analyze the impact of demand driven dynamic parking pricing policy on the demand for on-street parking spaces. Next is to investigate the effectiveness of dynamic pricing policy in reducing parking and demand during the peak hours and increasing parking turnover. To evaluate the potential impact of the dynamic pricing policy on congestion and traffic flow in urban areas. The last objective is to explore the feasibility and potential challenges of implementing dynamic parking pricing policy in real world urban environments. Let us start with the methodology of the topic. For the demand driven dynamic parking pricing mechanism, parking price changes desirably range for parking occupancy rate and threshold for price adjustment, and three important factors for the demand of parking pricing schemes. The aim of setting a desirable parking occupancy rate is to guarantee that the car driver can easily and empty parking space without spending more time cruising for parking when they arrive at their destination. Meanwhile, the utilization of the parking facility is maintained at a relatively high level. It is assumed that these factors vary at different levels. Parking simulation is performed continuously for 18 times interval. Each time interval lasts 4,000 tickets in the simulation software. The simulation for each time interval represents the parking simulation during 1 month. The parking price remains unchanged in the survey area during each time interval. After the simulation of each time interval, the average parking occupation rate of each road section and the proportion of section whose occupancy rate is outside the desirable range are updated for the price adjustment. Next is here is the block diagram of my PPT. Here you can see that this is the block diagram of my topic. Let's start with the working. It is assumed that car travelers can obtain real-time parking information before and during a trip. They can make parking decisions based on the demand-driven parking price and utilization of parking space. The decision rule during the cruising process for parking are shown. The parking decision-making process can be divided into three sequential steps. The first step is initial parking location choice before a trip, and before a trip, car traveler can use the mobile app to choose a road section to park their car based on the parking information around their destination. The parking choice probability for each road section are obtained using the on-street parking location choice model described. The road section with the maximum choice probability is regarded as the initial preferred parking location. Next comes the step 2. The driving process and the route choice during the trip, car traveler follows the car following rule while driving on the road. They accelerate on the declare according to the headway distance to the car ahead. When the car traveler enters the study area as shown, the car traveler agent can allocate the best route to them based on the initially chosen road section for the parking and the shortest path algorithm. Next is the step 3. The cruising process for parking. Parking firstly, each road section is divided into 3 continuous segments. Each segment has an approximately 6 step parking spaces. It is assumed that the traveler can see the parking situation of one segment ahead with their visual range while driving. So when the travel arrives at the initial chosen road section for the parking, they can assume to reach the first segment on the road section. As long as there is an empty parking space on the first segment, the choice probability for the parking is determined by the walking distance. If the walking distance is within the range randomly sampled based on the observed distribution, the traveler will park their car on the first segment and enter on the empty parking space. The walking distance is denied as the shortest path length from the center point of the segment on the road section to the traveler section. Otherwise, they will continue to drive to the next segment on the same road section and make a parking decision similar to the decision making process for the first segment. If there is no empty parking space on the 3 segments of the initially chosen road section, or the traveler do not choose to park on the road section, they continue to drive. At this moment, they need to reselect a parking place among the remaining available road section in the forward direction according to the decision rule of the step 1. So when the traveler arrives at the reselected parking section, their decision process follows the same rule as in this step. The car traveler can continue circling around the area to search for the parking place until the maximum cruising time is reached. They then drive away from the survey area. Cruising and driving times and denied as the time that the car traveler spent from the position where they enter the survey of to the position where their car is parked. If some traveler keep cruising for parking and do not park their car until the cruising driving time is continuously accumulated from the position where they enter the area based on the survey data, the maximum cruising and the driving time is set at 30 minutes in this study. Next, let's talk about the applications of the topic. The city planners can use the analysis to design and implement demand-driven dynamic parking policy that can reduce parking demand and improve the utilization of the parking spaces. Next, the business owners can managers can use the analysis to understand how demand-driven dynamic pricing policies can impact their customers and employees. The environment advocates can use the analysis to evaluate the potential environmental benefits of the demand-driven dynamic parking pricing policy. The policymakers can use the analysis to evaluate the effectiveness of the existing parking pricing policy and identify areas for improvement. The parking app developers can use the analysis to improve the accuracy, effectiveness of their parking search and pricing algorithms. These were the applications. Next, let us speak about the results of this topic. A reduction in the parking demand in high demand areas due to higher prices, leading to less congestion and increased availability in those areas. An increase in the parking demand in low demand areas due to lower prices, leading to better utilizations of those areas. An increase in revenue generated from parking fees due to high prices in high demand areas. A positive impact on the overall transportation system, as the reduction in the parking demand can lead to increased use of public transit and active transportation modes. The effectiveness of the demand-driven dynamic pricing may vary depending on the characteristics of the urban area and the user groups that it serves. The implementation of the dynamic pricing may face technical, social, political challenges which lead to addressed for the successful implementation. The dynamic pricing can be a valued tool for managing parking demand and reducing congestion in urban areas, but it should be integrated with other transportation management strategies for maximum effectiveness. The ongoing monitoring and evaluation of the dynamic pricing strategies are necessary to ensure their effectiveness, and adjusting prices are needed. Lastly, let's have the conclusion of this topic. So, the demand-driven dynamic parking pricing policy has the potential to be an effective tool for managing on-street parking demand in urban areas. The analysis of the impact of such policies on parking demand suggests that dynamic pricing can reduce the parking demand during peak periods and increase the parking turnover, thereby improving the utilization of parking spaces and reducing the congestion in the urban area. The successful implementation of the demand driven dynamic parking policy requires a careful consideration of various factors such as the availability of technology, data availability, and potential equity and social implications of such policies. The distribution of parking demand can be balanced, and parking and the traffic problems can be reduced. These are the papers which I had referred. These were the four papers which I had referred of the recent years. And thank you.